Okay, by request. So if you factor correctly, you know that the a value has to equal 1 over 2, which means sine 2x has to equal 1 over 2. If you have this point done, you know that sine 2x has to equal a 1. How about we do the easy one first? Yes? Sine 2x equals a 1. Right? Let's see, am I missing something? Okay, so that is equals to 1, which means 2x would have to be some form of pi over 2. Right? So in this case, again, I'm not going to actually say it's equal to pi over 2. All I know is that the reference angle is going to be pi over 2. Because it could be between, in quadrant 1, where else do we get a sign that's a positive? It could also be quadrant 2. Right? I don't know this. I just know that pi over 2 is involved. Right? And because it's positive, I know it's going to be in quadrant 1 or quadrant 2. Yes?
Does it say quadrant 2 or quadrant 4?
This is a 2.
Last time my calculator said it was pi over 2, but this time it just gave me a number, so does that mean it's not pi over 2? Wait, let me check.
Well, right now, it still should be pi over 2. However, so being in quadrant 1 and in quadrant 2, we're gonna have two different answers, right? Oh, wait a minute. This is 90 degrees. So it's not in quadrant 1 and quadrant 2. It's just one angle. I'm so tired. Sorry. Okay, so yeah, it's between quadrant 1 and quadrant 2. It's literally right there. Okay. So that means I don't have to worry about two cases. It's just one. 2x is, in fact, equal to pi over 2 plus, you never know, right? And every angle that is coterminal with pi over 2. Yeah. If 2x is going to be pi over 2 plus every coterminal angle of pi over 2, that means x is going to be pi over 4 plus any angle coterminal with, pi over 4 plus pi k.
Also, we divide the whole thing.
Well, you have to, because remember, that 2 means that the period is now smaller, right?
That's why we wait, right?
Yes.
And not divide.
Correct. Otherwise, you'll actually you will forget that it's actually every pi instead of every 2 pi. I'll say it one more time for everyone. If you have a 2 there, that means my new period, so old period is 2 pi, new period is pi. So if you hold off on the dividing, the old period, it's pi over 2 plus everything coterminal with pi over 2. But if you divide everything together, that 2 pi automatically turns into pi. So it's still coterminal. And you don't have to think about it. Everything is sort of reset for you so that you get pi over 4 and everything, not every 2 pi, but you get all the ones in between as well. Close this. Right. So The interval said it was 0 to 2 pi, which means what? X is going to be, it could be a pi over 4, it could be a 5 pi over 4, it could be a 9 pi over 4, it could be a 13 pi over 4. It keeps on going. How many of these count as my answers? Just, not all of them? Because it's 0 to, yeah, just the first two. Everyone's got to go. So I'll just, it's recording. So go check it out afterwards, okay? I'm going to continue moving on, but I know that you have to go to your game. Oh. Pardon? Okay. Yep. I got you. I'll take it anyways. Thank you. Good luck.
2 pi is all around like that, right?
Right now, because of it's a single pi. Because this was horizontally compressed, a full circle will occur every 1 pi.
Oh, okay.
So if it's 0 to 2 pi, well, these two angles are going to count. Tomorrow is a PA day.
Thank you, Mr. Kim.
Have a good weekend. Yep.
I heard that flag.
The other part. When we factored.
What?
Say that one more time.
You guys are on offense, that's fine. We're not gonna fix
That's the one we did.
Oh, wait. They're all on offense.
We're not done yet.
I'm the only one
Yeah,
on
we're just gonna do the other part, right? The other part.
Yes, of course.
Okay.
All right. So that was the easier one. See you later. Good luck.
Sorry. Thank you.
You better win. So again, if 2x is equal to half, what is the angle I'm talking about? Instead of writing it like this, because it might be confusing, how about I just write it as, what is the angle that I am dealing with right now? If sine is going to equal to 1 over 2.
Is it pi over?
Yeah. Sine of, no, it's got 30 degrees. It's got pi over 6. Yeah.
So here's 2x.
Right? It's going to be pi over 6, but what quadrant is it? Because it's a positive sign, it's going to be quadrant 1 and in 2. So we're going to have two cases here. Let's pretend we're in quadrant 1. Since the related angle is pi over 6, 2x is going to be equal to, well, this, which is pi over 6. Okay, leave some space. Leave some space. In Q2, 2x is going to be the larger obtuse angle, which in this case is going to be 5 pi over 6. And this would be enough if this was just some regular x and we are not dealing with larger, general equations and whatnot. But get into the habit now of considering this as an answer out of all the possible other coterminal angles out there. So that when you isolate x, this becomes pi over 12 plus pi k. so that you have two answers. If I am talking about an interval of 0 to 2 pi, x could be the answer that I just wrote, pi over 12, or add another pi to it, it could be this angle as well. If I added another one, in other words, if it became 25 pi over 12, that goes beyond 2 pi, so that doesn't count. Right. Again, quadrant, some people are still writing, but in quadrant 2, it's not just 5 pi over 6, it could be every coterminal angle with 5 pi over 6. So get used to doing this when they are asking for general solutions. That means x is equal to 5 pi over 12 plus pi k. Add an extra pi, it becomes 17. So if I were to group all that together, you have 6 different answers. Look at all the pinks. That one question has 6 different answers. Questions? Probably not. You're probably just really just jam-packed and you can't wait for the week to finish. Yeah, I hear you. I hear you. You have my empathy. Okay? I get it. I totally do. Tell you what, we're going to stop this video here. Let us go for our walk. When we come back, I will give you, we'll finish that example 6 together. It's a little grueling, but you need to know that even these do exist. It uses all your skills from previous years. And then we'll do some easier, lighthearted rate of change examples to finish the day. Okay? Grab your jackets. Let's get going.